without an eraser. Okay, and this one's calculator active, so I'm gonna grab a calculator. You may want to have yours too in case you need to remember something. And I know you guys love TIs, but I'm not going to use a TI. All right, so the area bounded by this region is this right here. Okay, so if you would shade it all. And if you remember, it's top minus bottom. So if I were to do this on an exam, I would first of all see that they intersect at this point. So that means I'm going to integrate from 0, so A is 0, to this point, 2. So I'm going to integrate from 0 to 2, and it's top curve minus bottom curve. So I need to know what this curve is, and if I take a look at this is exponential, and exponential looks like this. And since this is a parabola and it's negative at A parabola going down looks like this. So I say, and this is g of x, and this is f of x.
Why is it not 0 to 1?
I should have said 0 to 1. And here my attempt to do this without an eraser, I didn't even make it past that. Yeah, it's from 0 to 1. Thank you. And so I can simply type in my calculator. I would have one of these in y1 or y2, and I would just subtract them. But for work that the AP is going to want to see, they're going to want to see g of x minus f of x dx. So you're telling the grader that I know what a and b are, and you get a point for a and b. You know what the integrand is, which one comes first, and then they know you're going to do it in the calculator. So a and b are worth 1 point, this is worth 1 point, your answer is worth 1 point. So even if you write this correctly and write down the wrong answer, you got 2 out of 3 points, okay? Because to them, this is more important than how do you run your calculator. And I got this to be 0.224. Is that what you got, Matthew?
I'm not.
You're not that far, okay. We okay on that? Now, a lot of times what they'll do is they'll give you this as the first question, and then they'll have a part B. And a lot of times the part B is something called a cross-section. So a cross-section, if you recall, let's see if I can show you a 3D representation. So let's say I have this, and what I have right here is that length, and what's coming up is a square, okay? And then there's another one, oops, it should be parallel. That's actually not too bad for me. Another one, does that make sense? Those cross sections? And you have an infinite number of those. And they are dx thick because it says it's perpendicular with the x-axis. So you're really finding the volume of a bit, you know, like the chips you were eating, they're really thin, correct? But they're actually 3D. If you look at your piece of paper, it has certain thickness, right? It's a right rectangular prism. And so what I do is I always draw the cross section. It's a square. And they're going to expect that you know how to figure out the area of a square. Here's S, here's S. That means my area is equal to S squared. So S is equal to top minus bottom. So in terms of x, I have a function that's going to be g of x minus f of x squared. Okay? So I'm gonna come to my calculator here, and I'm actually gonna put these in here, and I'm just gonna show you some. I'm gonna put in 2 to the x power, and I'm gonna put in a negative x squared plus 2x plus 1. And it goes from, make my window from 0 to 1, and make my y from 0 to 2. And I'm going to draw it. And there it is right there. On a TI, excuse me, on this Casio, I can go to G-solve, and I want to figure out the integral, and I'm going to figure out from the intersection, that's going to be my first intersection, and then I'm going to go to my second intersection. I don't think you can do this on a TI. And there are shades in between, and that's where I get a 0.224 right here, okay? Now I'm going to leave that, and this is what you can do. You can go to your math button on your TI, and you can find where you can integrate. And again, I'm going to go to bars, and you have a bars button, and I'm going to have y2, because that was my second function, minus y1. I can't write y2 minus y1 as an answer. I have to say g of x, f of x. Everybody understand that? And this is going to be 1, this is going to be 0, and there's my answer, okay? Now, what I like about this is once I come and set up my integral like this, and you can do this on a TI also. If you go second enter, it'll give you your last line. And if you keep saying second enter, it will keep going back and back and back and back. Well, on a Casio, rather than press second enter, I can move up to there. And what I can do, because I don't want to retype everything, I can put my parentheses here around this and square it. It saves you a lot of time. Press enter, and that's my volume of cross sections. So all I need to do again is just show them this and then write the answer. So this would have been 3 points, this would have been 3 points. Again, for what they call the limits or the bounds, the integrand, and the answer. Are we doing okay? Now what we have here is the same region, but our cross sections are semicircles. And this is one that usually trips up some students. So what I do is I draw my semicircle, and I call this S. So again, you don't have to do this, but I need to work on my art skills anyway. So here's my graph, here's this. Let's see if I can draw a semicircle. So it's coming up like that. Does that make sense? I practiced this like every 2 weeks this summer when I was listening to something, well, when I was supposed to be listening to something I didn't want to listen to. So I know my area is 1/2 pi r squared. Everybody okay with that? This is the tricky part. A lot of people just take that S and put it in there, but that's not the radius, is it? This is really the diameter, correct? So 1/2 S is equal to R. So my area is going to become 1/2 pi times 1/2 S squared, and that's gonna give me 1/8 pi s squared. Is everybody okay where I got the 1/8? So now again, I write it like this. I bring it out front because it's a constant. 0 to 1, and it's g of x minus f of x. This s is equal to g of x minus f of x. I'm just going to write that down there. Square root of dx. Is everybody okay with that? Okay, now, this is already this portion, correct? That's this up here. Would you agree? So all I gotta do is multiply the answer by pi divided by 8. Again, it saves me a lot of time, doesn't it? And I got 0.024. And there's my 3 points, 9 points. Is this a pretty good review? Are you doing okay on this? Okay. So then, sometimes I can give it to you like this. So, if I were to go this way, I could have an integral going this way, but I would need a different integral going this way because this equation's different than that equation. Would everybody agree? So it's a lot easier doing it this way, and that's how I'm going to do these problems here. Now notice I draw that line. As soon as I do that, I call it that it's dy thick. So that means everything has to be terms of y. So what I'm going to do here is I'm going to make this y, and I'm going to solve for x, and I get y squared equals x plus 3. That means this is going to be y squared minus 3. That takes care of this whole thing, because if I would do the same thing here, square both sides, oops, I screwed up here by not making this long enough. If I square both sides, that negative is going to become the same thing, right? And then again, I write this as y equals x minus 3. That means y plus 3 equals x. So over here, this is y plus 3. So these gives you x values, correct? And this x value right here, this 3, is bigger than this negative 2. And my dad would say, duh, no kidding. I sent you to college to tell me that. Well, the idea is all the ones on the right are bigger than all the ones on the left. And so I rewrote this. And I come up with an integral that looks like this. Right minus left was y plus 3 minus in parentheses y squared, where did I write that? Y squared minus 3 dy. Now, I have to be integrating from here. Remember, they start up here and they go up, so eventually they'll be up over here. So I need to know what this y value is and this y value is. So I set them equal to each other. So I had, up here is where I did it. I said y squared minus 3 equals y plus 3. So they gave me y squared minus y minus 6 equals 0. I factored y minus 3, y plus 2 equals 0. So that means y equals 3, y equals a negative 2. So now I'm going from negative 2 to 3. And I rewrote this as minus y cubed plus y plus 6. And then I had a minus 1/4 y to the 4th plus 1/2 y squared plus 6y, evaluated from negative 2 to 3. And I got a negative 81 over 4 plus 9 over 2 plus 18 minus, and when I put a negative 2 in there, that's 16. I got negative 4. I did something wrong, didn't I?
Yeah, y should be squared.
Y should be squared where?
Odd one in the integral.
In here.
Negative y.
This should be squared, correct? And then this will be a 3, and that'll be a cubed, correct? Am I right?
Mm-hmm.
And so when I put a 3 in there, I'll get negative 9, won't I? Everything else is correct. And then over here, when I put a 2 in there, I'll have a negative 8/3 plus negative 2, I think plus 2, and minus 12. And when I computed that, I got it to be 20 and 5/6. This next one I did on my calculator because I'll show you why. First of all, again, these are cross sections and they're perpendicular to the y-axis, so this is my S. And it's rectangles whose heights are 3 times the lengths. So here's S. This is 3 times higher. So my area is equal to 3s squared. So I integrated from, again, a negative 2 to 3. I put the 3 out here. And s squared is going to be y plus 3 what did I ended up simplifying it to this, didn't I? S squared is going to be negative y squared plus y plus 6, that's squared. Well, they're never going to have you multiply out a trinomial, square a trinomial, so I knew that, so I said I just did it by my calculator. So I put this into y1, and so I had y1 squared, and I came up with 965. Letter C, it's an isosceles right triangle with one leg perpendicular to the y-axis. So here is one of my legs, they're the same. So this is S, this is S, so my area is 1/2 S squared. So I said my area in terms of y was 1/2 times a negative y squared plus 2y plus 9 squared. So I integrated from negative 2 to 3. So what did I went back to this work that I did here, deleted the 3, and multiplied by half. Does that make sense to everybody? Is that us?
Mhm.
Yeah, okay. We will finish this tomorrow.